everyone, and welcome back to Lowell Observatory's interactive stargazing. My name is Hannah, and if this is your first time here, welcome. Tonight we're going to be looking at a whole bunch of different objects through our Mallancam camera. So the camera that we're going to be using tonight is the Mallancam DS26C Tech. So this is a brand new camera that was donated to us by Mallancam. So we're super grateful and super thankful for this camera, and we're going to get some really cool pictures, all these different space objects. So if you guys have any recommendations of things you would like to see throughout the night, please leave them in the chat and we'll try to get to them. We have 30 minutes on the clock, so let's look at our first object, which is pulled up right now. So this is a crystal ball nebula. This nebula is also called NGC 1514. So for those of you who don't know, NGC stands for the New Galactic Catalog. It's just a way that we classify different objects based on the instrument that discovered them or a person or something like that. So NGC, New Galactic Catalog. This object is a planetary nebula in the constellation Taurus, which is about 2,000 light years away. So it's pretty far away. And as you can see, right in the center there is our little planetary nebula. So we got kind of a greeny blue color, and then we have a little white dot in the center. So planetary nebulas form when the smaller size stars die out. So we use our sun as a general reference for measuring other scales of stars in the solar system, in the galaxy really. And so we say our sun is about a smaller size star, smaller medium. And so stars that are around the size of our sun will end up dying like this in this planetary nebula formation. So what happens is the outer layers of the star, they start to swell up, and then eventually they drift off in different ways. So this one just happens to look circular, but there's new theories that kind of tell us that they're actually more of a cylindrical shape, like a soda can. Here is a soda can for reference. And what we're actually seeing with this one is we're looking down into the soda can. And there's some other ones where we're looking kind of side on. So we might see one of those a little bit later. But so just imagine that we're looking down into the soda can, and then right in the center, that little white dot, that is the white dwarf of the star. So of the star, I mean that's the leftover core of that star, and it's called a white dwarf. And so there's a lot of planetary nebulas up in the sky tonight. So let's look at one more, and then we'll start getting to your guys' suggestions. So let's go to the Cleopatra Nebula, or NGC 1535. And so while we go over there, we have this nice interface right in front of us to show how the telescope actually moves. So you're seeing that green dot move to that yellow dot. That's the telescope moving to that part of the sky. All we have to do is type it in, and then we take an exposure, and then we got it. And so these objects, they really don't require that long of an exposure. Around 10 seconds, maybe even less than that, depending on how bright they are. That's how good we can get these images. So if we zoom in on this little tiny feature here, we got another planetary nebula. And so this one, again, is the Cleopatra Nebula. It's in the constellation Eridanus. I honestly haven't really heard of that one. And it's around 5,000 to 7,000 light years away. And so this one, again, is more of a blue-green color. And so the colors from these planetary nebulas depend on what that star was actually made up of. And so the gas just represents a different element. So blue, I believe, is more associated with oxygen, and reds are associated with hydrogen. We see a lot of reds and blues when it comes to these planetary nebulas. And then again, right in the center there, we got our little white dot, which is our white dwarf, or the leftover stellar core of the star that died. So very cute little planetary nebula. And you can actually see some structure in there too. And so this one, again, how I said we look down on the soda can, this one's kind of like sideways. So you can kind of see that different structure that we get with these different objects. So we have a lot of requests already coming into the chat. So let's do some. So we have M31. So let's go see M31, the Andromeda Galaxy. So the Andromeda Galaxy is our closest neighbor major galaxy. It's pretty similar to our own galaxy. It's a spiral galaxy. Sorry, I'm looking at the chat, trying to keep up here. But yeah, it's a spiral galaxy. It's around 2.5 million light years away. And so what we're seeing right here in this image is the actual core of the galaxy. So it's really, really bright. It's a bunch of old stars that are really, really close together. So we get a really, really bright surface area, which is the core of the galaxy. And that is where the supermassive black hole lives. And then around it, you can kind of see these darker stripes. Those are the arms of the spiral galaxy. And that is where the active star formation happens. So that's where all the gas and dust and little baby stars, old stars, exosolar systems, planets, all these other things, that's where those things live. It's kind of the younger area. So the Andromeda Galaxy actually spans really far out, and it's actually, you can actually see it with your naked eye. It's a really, really cool object, and I recommend trying to find it if you can. If you have a dark sky near you, it's a really awesome thing to see. And lately, for some reason, it's been looking really bright. So, oh, and we just kind of made it a little bit brighter there so you can actually see the spiral arms a little bit more. See that gas and the dust. You can't see the little individual stars, but with other really high-grade telescopes like Hubble Space Telescope, stuff like that, you can actually see other stars in that galaxy. But to us, here on Earth, can't see nothing in there besides the galaxy itself. Okay, let's see. We have M42. So let's try M42. So M42, oh, okay, perfect, the Orion Nebula. So there's a lot of catalog numbers and names, kind of hard to remember them, but as soon as I see the actual name of what it is, it's a little bit easier than to remember letters and numbers. But the Orion Nebula, it's in the Orion constellation, just like after its name. And so the Orion Nebula is a star-forming region. So this is where the little baby stars are born in that big cloud of gas and dust. It's so dense that some regions actually collapse upon themselves and start stellar fusion or nuclear fusion, start making these little baby stars. And so that's what that really bright area is. That's where all the bright stars, the bright baby stars are. And so baby stars, they're just like regular babies, where they like to throw tantrums. And so these baby stars have a lot of stellar wind, and they blow gas and dust in all sorts of different directions. And so that's why it looks like it's kind of opening there. It's because that stellar wind's so strong, it's actually blowing the nebula apart. So, and then again, we have the different colors of the gas and dust there, just like with the planetary nebulas. It represents the different elements that the gas is made of. Okay, very cool object. Let's try Mars. So I have a lot of favorite planets. I don't have like one favorite. I love Saturn, and I love Earth, and I love Pluto, but I love Mars a lot. A lot of the research that I do is on Mars. Mars is very near and dear to my heart. Mars has a little orangey red tint to it, and that's because of a lot of the iron oxide on the surface. Just this past few months, Mars was actually at opposition, so it's at its closest to its orbit to Earth. And so we could actually see a lot of surface features on Mars. Now it's getting a little bit further away, so can't see a lot of those surface features anymore. But we have something really cool happening here. In like 2 days, the Perseverance rover is actually landing on Mars. So that is super cool. How that rover is landing is it's not having any input from Earth. We're not like giving it directions like, all right, you're going to land here. It's already pre-programmed. So we don't know if it successfully lands until a few minutes afterwards. And so it's a really, really intense event, but it's super cool. We have another rover going to Mars, seeing if there's going to be any evidence of life in Jezero crater. So that is the landing site for Perseverance or Mars 2020. So keep an eye out for that. I don't know if we're doing a live stream for that. I'll reel back with that if we are doing a live stream with that, but super, super cool. Stay tuned. Okay, so we got a lot more objects. Let's see. All right, so we have a request for Pluto. So unfortunately, Pluto is not up right now. Pluto usually is up towards the fall for us, in the fall sky around Scorpio, that kind of area. So unfortunately, we don't have Pluto. If we have enough time later, I could show a picture of Pluto that we do have. Again, it's really far away, really tiny, really can't see it, and it's not up right now. So I'm so sorry about that. So someone asked for Uranus. So yep, we have Uranus up. So let's go head to Uranus real quick. So we don't really have a lot of planets up tonight, unfortunately. Again, a lot of the planets are more of like a fall object, fall, winter objects. In the spring, coming up spring, summer, yeah, we don't really have a lot of planets up. But so here is our little planet Uranus. It has a faint baby blue glow to it, and that has to do with methane and ethane. That's in the upper atmosphere of this ice giant. So Uranus is really, really far away. It's a little bit different from Jupiter and Saturn compositionally because it's so far away and it's so cold that its interior, they actually think there possibly could be a core, and it would be made of ice and rock and stuff like that. And so it's called an icy gas giant. And then in this picture, we actually have two of the moons of Uranus. Don't know which ones they are. So yeah, I don't know which ones they are, but those are two moons of Uranus. So really cool that we can see those. All right. Okay, so we have a recommendation for IC2162. So we know it's a bright nebula in Orion, but I don't think we've actually looked at this before. So we're gonna all see together what it looks like. So right here, they're actually typing in the name of what it is, and then we're gonna go to it. So yeah, really interesting to see what it is. In just a few seconds here, we'll get that exposure. So yeah, we're probably gonna have to turn up the exposure just a little bit so we can see it a little bit better. So while we're there, let's look at some, let's see, other recommendations. Oh, okay. I see 2162. It's a bright localized nebula, emission nebula in Orion, better known as Bernard Hubble. Interesting. Okay, so I see a little bit of nebulosity in this region. Yeah, I don't personally know too much about this area. There are so many different nebulas in Orion. So a little fun fact about Orion is it's just a really amazing part of the sky. There's so many different emission nebulas and just stellar nurseries and things like that in that area. It's just a really populated, gassy part of the sky. So there's so many different things in that region. So yeah, I do see a little bit of nebulosity. We'll let this 30-second exposure kick in, see if it makes it a little bit better. Oh my God, that is so cool. So look at that. So yeah, we got a little bit of red, got like two lobes, and I think I see like a third one on top. That is really cool. I think it actually looks like two eyes that are looking at you, two red eyes. That's a really cool region. So thank you for that request, Tom C. So awesome, thank you. Okay, so we have a request for a comet. Can we see any comets? Unfortunately, it's a little bit trickier to get comets in the night sky with this, just because you have to know exactly where it is. And sometimes with comets, they just look like the background of stars. So that will be a little bit of a more time-consuming one. So we'll try that maybe next time. But yeah, again, it might be too small. So let's see. NGC 2174, a bright emission nebula in Orion. Yeah, let's try that one. So like I was saying before, Orion's just crazy cool, has so many things in the sky. There's really so many things to look at over there. I don't know what else to say. It's really awesome. So let's go check it out. And so let's see what other ones that we have. So someone asked, can we see what is your favorite one to look at? Okay, I have something. I have a favorite thing to look at. We'll look at it a little bit later, but I wrote it down, so we'll get to that. Thank you for that request, Maria. Okay, so what is this again? NGC 2174. Okay. So yeah, again, it's just a bright emission nebula. So what emission means when it comes to nebulas? So basically it means that this gas is being excited by something in the region and that it's emitting photons to us. That's basically what emission means. So there's different types of nebulas. There's like emissive, there's reflective. I have to go back to my astronomy books. I don't remember a lot of them. There's planetary nebulas, stellar nurseries. So there's all those, but there's lots of different types of nebulas basically. But this is a really cool region as well. So very red, lots of hydrogen alpha gas in there. We see some bright little stars, which is really cool. So yeah, really cool gassy area in the sky. Love it. Something else to point out here with this nebula, to that left there in that red region, it's like bubbly, like clouds. And so what that region is that there's just that gas that's so dense and it's so thick that it's actually kind of blocking out light that's coming from around that area. So I think that's how the Horsehead Nebula is, how the Pillars of Creation are. That's how they look to us at least. So yeah, really cool. All right, so someone requested for NGC 2467. Oh my goodness, unfortunately that one is too low. So I'm so sorry about that, but we have another one, BeetleJuice. So let's go see BeetleJuice. Yeah, let's go see BeetleJuice. So BeetleJuice is a red supergiant star. There was a point in time a few months ago where we thought it was going to explode, and we do think it's still going to explode, but not anytime soon. So a few months ago, it had a little fiasco where it was like dimming a little bit, and people were like, oh my gosh, it's dimming out before the Big Bang that it's gonna happen. And that was not what was happening. Basically, these old red supergiant stars, when they get towards the end of their life, they start spitting out gas. And so that's what BeetleJuice was doing. It was spitting out gas and dust. And so this gas and dust cloud actually was just passing in front of its field of view to us, plane of sight. And so it was kind of dimming it a little bit. So that's what was happening a few months ago. So it's back and bright, better than ever. So that's what we got with BeetleJuice. It's the top shoulder of Orion there. So yeah, but it will blow up someday, but we don't think anytime soon. So let's see more requests. Okay, so let's do the favorite thing to look at. Okay, so let's try the Running Man Nebula. So again, this is in Orion. We're like super excited about Orion tonight. Everyone's requesting things in Orion. That's totally fine. Orion's, again, super amazing. And so Running Man Nebula, it's a nebula that looks like a man or person that's running. But I like this one because it's really, really blue. So we'll see here in a few seconds how blue it looks. Let me read through some of the other suggestions while we let the exposure come in. Again, you can see a lot of that blue starting to come and pop out. You can see the really bright stars. And so underneath where we just put our cursors, where that Running Man will be, and I think it's like kind of sideways. We'll see once the exposure gets a little bit better. We'll see that. Okay, so people are requesting, okay, M33. So M33 is too low in the sky, so it really isn't going, oh, sorry, it's not so low, but it's going to be really washed out by the moon. So the moon is up tonight, and it's close to the moon, so it's going to be washed out. So I'm sorry, no M33 tonight, but that also means that we could look at the moon after this. So let me talk about this really quick. So it looks like, I think he's upside down, maybe right side up, but that area underneath the blue nebula, that is the Running Man. And so again, this is a new camera that we got, DS26C Tech Malincam. This is such an amazing view of the Running Man Nebula. Before, it was really zoomed in and you could just kind of see the guy. But now it's so zoomed out and you can see the whole part of the nebula. Yeah, that's kind of like what the field of view looked like before. It was like super zoomed in. You couldn't really see a lot of it, but now we got this whole field of view, awesome nebula around it. So that's a really, really pretty one. So I think that's one of my favorites in the sky right now. Again, there's so many different things. Okay, so my telescope operators actually just let me know that we can see the comet. So Comet Atlas is the comet that was requested before. And so someone else, while we're looking that up, someone else requested the Andromeda Galaxy. So we already looked at that one. If we have enough time at the end, we'll go back to the Andromeda Galaxy. But don't worry, this video is saved as soon as the live stream is done. So you can just go back towards the beginning of the stream and look at the Andromeda Galaxy. So it'll still be there for you. Okay. So someone else requested NGC 2359, but it is too low. So I'm sorry about that. Thor's helmet. Yeah. Okay. So we're trying to get the comet, I believe. Yeah, let's see. Again, let me look through some of the other suggestions that we have. Just a reminder, by the way, if we don't get to your request tonight, or we're unable to see them because they're too low or something like that, we have these live streams every single week on Tuesday night, depending on the weather. So in Flagstaff, it's been a little bit cloudy, a little bit snowy lately. So again, it's weather dependent, but every Tuesday night at this time, we do this live stream. So if we can't get to it today or it's too low, there's plenty of other opportunities to see these objects. And with the seasons changing and stuff like that, new objects will be coming up. So cool. Okay, so yeah, I think we're having a little bit trouble finding the comet. I'm sorry. So let's just go to something else. Maybe some other day I'll personally try to take pictures of the comet and blink them and see if we can get that, and we'll post it. So let's see. The Pleiades. Let's do the Pleiades. So yes, the Pleiades are up right now. It's so crazy because it's been so cloudy and snowy lately that some of the last times that I actually worked some shifts at the GODO, at the Open Deck Observatory, the Pleiades were just starting to rise, but now they're just like straight up in the sky. So yeah, let's head over there. I can see them. So that's what's super cool about our software, is that you can actually see the different constellations. You can see the little stars. And so the Pleiades, they're just right before Taurus there. So you can see the little cluster. So we are the Pleiades. Let's talk about the Pleiades. So the Pleiades is an open cluster of stars. There's two different types of clusters when it comes to stars. There's globular clusters and then open clusters. Open clusters are younger stars. Globular clusters are older stars. And so these young stars form in a stellar nursery. And that stellar nursery, just like Orion, they're making these baby stars. And that gas and dust gets blown away or gets eaten up by stars and makes planets and stuff like that. And then we're left with these stars that are kind of close together. And then as they get older, they start to gravitate, they start to interact with each other. Their gravity starts to interact with each other, and they start to like kind of tug and pull on one another and like push each other away, and then they start to spread out. And so with the Pleiades, they're all kind of spread out here, and it's a really wide field of view, so our camera doesn't get all of them. So we got a few of the stars in the Pleiades. So like that bright one right in the center is part of the Pleiades. The one to the top left is part of the Pleiades. Again, just really bright stars kind of all over the place. And it kind of looks like a Little Dipper in the sky. So the actual Little Dipper, the constellation, is pretty big, but this one is really, really tiny. It looks like a really tiny Little Dipper. So sometimes people are like, oh my God, is that the Little Dipper? And that's actually the Pleiades. Another kind of reference to the Pleiades is the Subaru logo. So the Subaru logo is of the Pleiades. And so I thought that Subaru translated to Pleiades, but Subaru actually means to govern. And so to govern the Pleiades, what that means is that the Pleiades is basically governing the bull Taurus and like leading it in the sky. So that's, I believe, what the actual translation of Subaru means when it comes to the Pleiades, which is really, really sweet. I love that. Okay, so we're getting pretty close to time here. We have 5-6 minutes left. So let's see what else that we got? Okay, Pleiades. Rosette. So the Rosetta Nebula NGC 2237. Let's try that. Okay, we'll do that. Okay, and then someone else requested the Zetta Reticuli system. That is the coolest name ever. Oh my gosh. Unfortunately, that one is not up. So sorry. It's in the southern hemisphere. So we can't see that, but that is a really, really cool name. All right. Okay, so we'll look at this object, maybe one more, and then we're going to end on the moon. So let's see what we got. I forgot even what we're moving to. The Rosetta Nebula, NGC 2237. And so back before I was talking about how NGC stands for the New Galactic Catalog, there are thousands of objects in this catalog. I cannot begin to tell you how many objects there are. Some of them are really, really faint where you need a really high research grade telescope to see them, again, like Hubble or something like that. And then some of them are bright enough where we can see them here on Earth. And so the reason why there's these vast amounts of differences is not only that these objects are far away or they're really faint and tiny, but also viewing things from Earth is difficult because we have our atmosphere obscuring a lot of the view that we can get. So these telescopes that are in space, they don't have anything blocking their way, so they can see it really well. But on Earth here, we got a lot of obstruction in the way that's a little bit difficult. But okay, here is the Rosetta Nebula. Again, it's a little bit more of a fainter one. If we had enough time tonight, we would crank up the exposure and let it sit there for maybe a minute or so we can actually get it. But we do not have that time, unfortunately, but that it still picks up. So that's cool. Okay. So the cursor there is just pointing out to where that is. So let's do one more, the Eskimo Nebula. So NGC 2392. So we actually call that one the Clown Face Nebula. The Eskimo Nebula is an old name that we don't really use anymore here at the observatory. So the Clown Face Nebula is this one. Yeah, it's just outdated term. All right, so this one, again, is just like with the objects that we started in the beginning of the night. It's a little tiny planetary nebula. And so this one's really, really cute and tiny. It's really blue. And so if we zoom in there, we can see our little white dwarf and we can see some structure. And oh, I love this one because with our new camera, it comes in so well, all that structure and everything. And so this one's just super cute, super tiny. It's just hanging out there. Just our little circle. Ah, so cute. I love it. Okay, so that is the clown face. So let's end on the moon. So let's go to the moon. So I actually haven't seen the moon tonight. I think it's like half phase. I don't know. I really haven't been getting out much lately. But that is where we're going right now. And again, the field of view of this new camera is so awesome. So with the last camera that we had, we could get maybe half of the moon. Now we basically can get the whole entire moon in the screen, so which is really nice. So we're going to play around with it just a little bit. The moon's very, very bright, and the reason why that is, it's reflecting a lot of sunlight. So that's the whole reason why we can see the moon, is because of the sunlight being reflected off of it. So while we play with that, I'm going to give a shout out to the I Heart Pluto Festival that is happening right now, all this week. Go to the Lowell Observatory website. Should have a link to the I Heart Pluto Festival website. If not, I believe the website is iheartpluto.org. I'll be corrected on that in just a second if it's different. I believe they're going to put the link in the chat as well if you guys want to go to the website. Yeah, that's right. So iheartpluto.org. And the link will be in the chat. And we're having talks every single night. We started off the festival with talks by Alan Stern. He was the principal investigator for the New Horizons mission. That's the spacecraft that went to Pluto. And we had some talks with astronauts. We had some tours of the Pluto Discovery Telescope and of Mars Hill. So for those of you who haven't been here and would like to see what campus actually looks like, those videos are available on the YouTube channel. We have so many other really cool events that are going to be happening. I believe one just happened before this, and we have some happening tomorrow night. So go check out what we have going on. It's a super exciting thing that we have once a year around this time, Pluto's discovery date. So yeah, so that's all that we really have time for tonight. My telescope operators are in the frigid cold weather out in Flagstaff. It's really cold, so I'm gonna let them warm up. Thank you all so much for tuning in. And I hope you guys enjoyed all the objects that we saw. We had some really, really cool objects. Yeah, thank you so much.